Okay guys, good afternoon. So, in today's video, I will discuss about our nodal analysis. So, actually, in our circuit analysis, hindi kaya nung Ohm's law, hindi kaya nung Ohm's law yung mga ibang circuits natin. Because Ohm's law can be used when there is already a resistance, a current, and a voltage present into the system. So, how about if one of them cannot be found on the system? So, dyan pumapasok yung other circuit analysis natin, which is your, number one, is your nodal analysis and your mesh analysis. So, we have what you call your nodal and your mesh. Okay? So, in this lecture, I will discuss your nodal analysis. So, what is a nodal analysis, guys? Your nodal analysis, from the term itself, a node. Okay? So, if, let's say, I have a circuit, yan. Let's say this will be R1, R2, R3, and then your current source. Okay. So, let's say I have a node wherein I will indicate my node as node A. Okay. So, when you are using your nodal analysis, you must have a continuous Kcl. Pag nodal analysis yung ginagamit mo, you must have your continuous Kcl. What is Kcl? Your Kcl is your Kirchhoff's current law. So, according to Kirchhoff's, your Kcl is the summation of current going into the node, going in and going out into the node, wherein its sum is equal to 0. Summation of I is equal to 0. So, inuulit ko lagi sa inyo from our first examples in Kcl and KVL is that when you are already designating the direction of your current is that wag nyo na siyang papalitan. So we have, let's say this is your I total. I have my I R1. I have my I R2. Okay? So as you can see, if you will use your nodal analysis in that one, so you would use a Kcl method. In Kcl method, so we have, let's say Kcl at A, we have at A, you have I total going into the node minus your I R1 and minus your I R2. Take note that your I R2 and your R2 and R3 in series, therefore your I R2 is equal with your I R3, right? So upon indicating the current in our circuit, the next thing to do is to indicate a ground. So, anong gamit ng ground na to? Your ground will indicate as a datum for zero potential. Ibig sabihin yan, yung ground mo, siya yung parang magiging base mo. Which means, yung voltage dyan is equal to 0. Okay? Voltage at ground. Take note na ginamit kong Vg is equal to voltage at ground. Okay? And then, you will indicate a voltage in each node. So, since I have a node here, or your A, I will indicate it as your VA. Okay? So, what is VA, guys? That is the voltage of your R1, which is equal to the voltage of your VR2 plus VR3. Okay? So, from the steps of nodal analysis that I have discussed into your module, so therefore, I may say that your IT is equal to IR1 plus your IR2. Take note, may equal 0 tayo dito kanina. Because your KCL is based on the law of conservation of charges. Okay? So we have IT is equal to IR1 plus IR2. But what is our IR1 and our IR2? So, take note that according to our nodal analysis, that our voltage at a node is equal to our VA. Right? So, what are the resistance connected in this node? Since there is no voltage or current on the node, therefore I may say that my VA is the voltage in your R1 and R2 and R3. So, indicating or using your Ohm's law, I may say that my VA is equal to I R1 multiplied by my R1. Also, since the combination of the series combination of R2 and R3 is in parallel with my R1, therefore I may say that my VA is also equal to I R2 multiplied by R1 plus R2 plus R3, right? So, based on this explanation, your nodal analysis, therefore, is equal to IT, right? IT, yung current na pumasok, positive yan, is equal to our IR1, which is equal to VA divided by R1, right? Pag dinivide mo yung R1 dito, okay? So, indicate ko yan, right? Plus your VA all over R1 plus R2. R3 plus R2, okay? This is your I total. Solving for I total, take note yung I total nyo, pag independent current source yan, it is a constant, okay? So, ang gagawin natin is solving for our VA. Our VA in this equation is dependent to your I total. The independent variable is your I total and the dependent variable is your VA. Okay? So, we have solving for our VA. We have VA is equal to, so factoring out your VA, we have 1 over R1 plus 1 over R3 plus R2, right? R3 plus R2 is equal to your I total. Mapapansin nyo na yung IR1 plus IR2 nyo is can be solvable. Solvable siya, di ba? Or I may say that my VA is equal to I total divided by my I divided by R1 plus my my 1 divided by R3 plus R2. Okay? That is our VA. So take note, since only one node yan, tapos iisa lang yung source natin, it is not that complex. Madali pa yan, di ba? Okay. So, there are 3 cases in your nodal analysis. Okay, yung number 1 is nodal analysis wherein current source only. Nodal analysis, number 1 we have analysis. Our first case is that it is a current source only. Pag current source lang yan is that it is just continuous KCL lang yan. Current entering and current going out, ganun. And then, the second one is your voltage source. Okay. Your voltage source case has 2 cases. Meron tayong tinatawag na your voltage source can already be the source of that node. And then second one is that it is a super node. Okay? Later on, I will solve for the supernode and your plain voltage source, wherein your voltage source will be on the sides or on the node of the circuit. So voltage source wherein the voltage source is equal to the voltage at the node of the circuit. Voltage source is equal to voltage at the node and second is your supernode, wherein hindi lang KCL yung gagamitin natin. Because when you have a supernode is that you will also use a KVL. Because if your voltage can be found in the two terminals of a circuit wherein it is not connected to your ground, therefore, we may say that that supernode can be used as one node. So, lahat ng pumapasok at lumalabas na case na current sa node na yan is that it would be solved in only one equation. So, let's say this is an example of your supernode. Okay? Yan. Sir, bakit siya example ng supernode? Okay. Example siya ng supernode kasi nga, itong voltage na to, if I will indicate this as my ground, okay, as my datum, therefore, your voltage source in this V1 and V2 is directly connected to the terminals of your, let's say, R1 and R2. It is not connected to the ground. Ibig sabihin nun, wala siyang datum. Okay? So therefore, ang gagawin natin, i-connect natin itong voltage source na to sa ground. Okay? So, paano yan? By letting it whole node. Okay? Take note that the voltage here, let's say VA and VB, since your voltage source is already connected to the ground, I may say that your VA is a voltage of this node. Okay, voltage na yan ng node na yan. And then yung voltage din ng node na to is your V3. Kasi yung V3 mo, connected siya directly dito sa ground mo. Yung pagkakaiba niya sa supernode is that, take note of the terminals of your supernode. So mapapansin mo na itong positive and negative terminal ng voltage source mo is that it is connected with the terminals of V1 and V2, which is not directly connected to the ground. That is your case 2. Your case 1 voltage source is indicated in your VA and VB. Okay? So, pag meron kang circuit, so let's say this is positive negative V1, directly connected to the ground. So, sige, hindi muna natin nalagay yung ground. Okay? So, pupunta tayo sa process. So, we have V1, and then your R1, R2. And then, let's say this will be your R3. And positive, negative, V3. So, take note, this is your case 1. Bakit siya case 1, sir? So, assuming na naglalagay ako ng ground. So, take note na pwede kong isulat ito na ganito. Yan. Positive, negative V1 connected to the ground. Your R1 connected to the ground. Your positive, negative V3 connected to the ground. Okay? And then your R1, your R2, and your R3. Yan. This can be rewritten into this circuit. So, mapapansin mo that your V1 is directly connected to the ground. And also your V3 is also directly connected to the ground. Therefore, at this node, at node A, let's say this will be your A and B, the voltage in that source is equal to your V1 and V3. That is your second case wherein your voltage source yung source natin. So, pwede bang maghalo? Oo, syempre, pwede maghalo. So, pag naghalo sila, guys, use the theories that were defined on each source analysis. So, if you have your current source, so, gawin mo lang, Kcl. Di ba? Pag voltage source, Kcl lang din. Right? But, I will elaborate more of these theories as we go on with our examples. Okay? Okay, guys? Let's have our example number 1. So, in this example, we are tasked to find for your V1 and your V2. Right? Find V1 and V2. Pag gumamit ka ng simple ohms law dyan at series and parallel resistance, okay, how will you do it? Di ba? Paano mo i-solve yan? Di ba ang hirap, guys? So, dyan pumapasok yung tinatawag nating nodal and your mesh analysis. But in this case, let us solve this using your nodal analysis. So, using nodal analysis. Okay. Ano yung step 1 natin? Yung first step natin is to, if walang node, wala siyang ground, therefore, our first step is to put our ground. Okay? So, if there is already a ground there, so therefore, we may say that there is already a zero potential into your circuit. Okay? So, since there is already a zero potential in your circuit, we may now assume the direction of current. So, take note of the word assume. Yung assumption mo is that ito yung magiging guide mo in solving for your current. So, let's say, I have my V1. So, ang gusto kong i-assume na lahat ng current ko is papunta sa ground. Okay? Let's say this will be my I5 and I10. And also, I will indicate it as my I3, I4, and I will indicate this current as my I2. So, bakit ko ginawa yun, guys? Para hindi tayo malito later on. So, we have I10, I5, I4, I6, I2. Bakit I2, I5, I4, I10? Pwedeng I1, I2, I3, I4. Actually, guys, kaya linagay ko yung subscript is 10 ohms, 2 ohms, 5 ohms in order to indicate that that current is going to your resistor. Resistor 10 ohms, resistor 5 ohms, resistor 4 ohms, and resistor 2 ohms. Alright? So, since meron tayong indicated current and also direction, the best thing to do is to select our nodes. Since sinatanong niya yung find V1 and V2, therefore, it is safe to say that I have 2 nodes, my V1 and V2. Okay? So, kung ilan yung nodes mo, yun din yung bilang ng equation na gagawin mo. So, pag mapapansin mo na pag tatlo yung nodes mo, therefore, tatlong equation yung gagawin mo. Pag 4, 4. Pag 5, 5. The problem is that, di ba? Pag mathematician ka talaga, madali lang isolve ang 5x5 equations, ang 4x4 equations, and 3x3 equations, right? Actually, ang gagawin natin dyan is matrix form, tama ba? Pag 4x4, 5x5, 6x6 na. Okay? Yan yung sinasabi kong pahirapan, no? Mahirap na yan, guys. Hindi kasya ang isang oras yan. Pag nagkaroon ng 5x5 equations, kahit 4x4 equations pa. Okay? So, since this is these circuits, your equations or your equation is composed of real numbers. Pero, pag nasa AC analysis kayo, dyan pumapasok yung combination ng tinatawag nating complex numbers. Okay? Complex numbers ang i-analyze nyo. So, since this is just a basic, guys, so we are analyzing real numbers. So, we have V1 and V2. So, may dalawang node tayo. Ibig sabihin, meron tayong dalawang equation. So, how will we solve for the two equations? Dali lang, di ba? Using your KCL, KVL. Okay. At node 1. At node 1. Right? So, let's say, this will be node 1. Node 1. And this will be your node 2 at V2. Right? So, what are the currents entering and leaving your node 1? So, ito nakakalit to. Yung I2 mo. Take note na nag-leave siya sa node 1 and then papasok siya sa node 2. Okay? Baka mamaya ang gagawin mo since nag-leave siya sa node 1, mag-leave ka rin sa node 2. Wag guys, wala nang matitira sa iyo, di ba? Joke lang, sige. Okay. At node 1, we have what are the currents entering and going out your nodes? So, we have our 10 ohms. Your 10 ohms is going out your V1. So, we have negative I10. And also, your 5 ohms is going out your node 1. Negative I5. And also, your 6 ampere is going out your node 1. Minus 6 ampere. And then, your 2 amperes is going out your node 2. Minus I2. Since this is KCL, conservation of electric charge, so summation of I is equal to 0. So therefore, I may say that my I2 plus I10 plus I5 is equal to 6 ampere. That is our KCL at node 1. But what is our I10? I2, I10, and I5. Take note that since yung V1 mo papunta siya sa ground natin, this is V of 0. Meaning, your ground, VG, or your voltage at your ground is equal to 0 volts. Okay? So, pag gumawa ka ng KCL, ng nodal analysis, therefore, kung saan ang galing yung current, yun yung mas malaki papunta siya sa mas maliit. So, V1 minus VO all over 10 ohms. Okay, that is your I10. But what is your VO? Your VO is equal to your VG, which is equal to 0, right? So, therefore, my I10 is equal to V1 minus 0 all over 10. So, therefore, it is equal to V1 over 10. Yan. Okay? Napakadali, tama? Next is our V5. I5. What is your I5, guys? Okay, hindi siya nagsusulat. Yan. So, our I5 ohms is equal to, so saan connected, saang node sa affiliated? Your V1, di ba? So, V1 minus VO all over 10. Tama? All over 5. Kasi 5 ohms. Tama? So, since VO is equal to 0, so therefore, I may say that it is equal to V1 minus 0 all over 5. Or it is equal to V1 all over 5. That is your I5. Next is your 2 ohms. So, what is the current in your I2? Easy, tama? Madali lang. So, yung sinabi ko sa kanina, yung nodal equations of voltage yun, nodal voltage equation is that it is equal to V upper potential minus your V lower potential all over your R. Kasi pag nodal analysis, ang kinukuha natin is that yung current. Okay? Your I12. Okay. So, since meron tayong I2 dyan, so I may say that my I2 is equal to I12. Which means that I connect from node 1 to node 2. So, we have V1 minus V2 all over 2 ohms. So, that is our I2. Substituting the values of your I1, I2, I3, and I2 I2, I10, and I5. Therefore, substituting the value, substitute. So we have I10 is equal to, I2 is equal to V1 minus V2 all over 2. That is your I2. That is your I2. Yeah. Plus your I10, which is equal to V1 over 10, plus your I5, which is equal to V1 over 5, is equal to your negative 6 ampere. Yan. So, negative 6 ampere to, di ba? Kasi pag nag-transpose ka, may iwan yung negative mo. Okay? So, negative 6 ampere. So, anong next na solution natin, guys? So, we will add the same variables of your V1 and your V2. Yan. So, therefore, I may say that it is equal to V1 over 2 plus V1 over 10 plus V1 over 5 minus your V2 over 2, which is equal to negative 6. Yan. Okay? Factoring out your V1, we have V1 multiplied by your 1 half plus 1 over 10 plus 1 over 5. So, using your calculator, please calculate the value of this equation. We have 1 half plus 1 over 10 plus 1/5. So therefore, we have a value equal to 4 over 5 V1 or 0.8 V1 minus V2 over 2 is equal to 0.5 V2, which is equal to negative 6. This will serve as your equation 1. Right? That would be your equation 1. Okay? Next is our equation at node 2. At node 2. Yan. What are the currents entering and going out your node 2? So we have positive 6 ampere, pumasok siya sa V2. So positive 6 ampere, and then yung I2 mo pumasok siya sa V2. Plus I2, ito, plus I2, plus your 3 amperes kasi pumasok din siya sa V2. Mapapansin mo yung arrowhead. And then, I indicated that your V2 or your V4 is going out the node V2, which means papunta siya sa V0. So, it is going out your V2, so therefore it is equal to I4 equals 0. Your setting up of equation in your nodal analysis and your mesh analysis is very critical. So, pag nagkamali ka sa pag-set up ng equation mo, therefore, no, asahan mo na mali ka sa sagot mo. Okay? So, we have I2, negative 4, and equals 0, and 0. So, what is your I4? Your I4 is equal to V2 kung saan yung upper potential mo minus your lower potential, which is your VO, all over 4. Another use of your voltage, your ground, is that it would set as the lower potential for those nodes that has no voltages connected to them. Okay? Next. So, V2 minus VO over 4. That is your I4. Okay? So, pag hindi nyo maintindihan itong discussion na to, guys, meron akong isa-send na book sa inyo. It is a book by Sadiku, which is our reference. Okay? So, I4 is equal to V2 minus VO over 4. Okay? So, let's solve for the equation of your node 2. So, we have 6 plus what is your I2? I have indicated that your I2 is equal to V1 minus V2 all over 2. Okay? So, V1 minus V2 over 2. So, papuntayan na huwag niyong babalik rin yung sign. So, V1 minus V2 divided by 2. Right? V1 minus V2 divided by 2. Sir, paano pag ginamit ko yung V2 minus V1? E di, gawin mong negative, di ba? V1 minus V2 all over 2. Plus your 3 amperes, which is going to the node, minus your I4, which is equal to V2 all over 4, which is equal to 0. Bakit siya naging V2 over 4 na lang, sir? So, balik ka sa sinabi ko kanina. That the theory is that V2 minus V sub O, since it is on the ground, therefore V sub O is equal to Vg is equal to 0. Okay. In other problems, hindi lahat ng VO mo is equal to 0. Sometimes yun lang yung indication ng unknown. So, in my problem kasi, ang ginagawa ko is that your VO is equal to your Vg, wherein it is equal to 0. Your Vg is the ground. Okay? In this case, that is that my Vg is equal to my VO. Okay? Which indicate that voltage 0 or 0 volts. Okay? So, we have V2 minus 0 all over 4, which is equal to V2 all over 4. Right? So, solving for this equation, I may say that katulad ng ginawa natin kanina, lahat ng V1 and V2, pag-isahin natin. Okay? So, we have positive 6 plus V1 over 2 minus, wala, diba? Minus, wala. Plus 3 minus V2 all over 2 minus V2 all over minus V2 all over 4, which is equal to 0. Right? But what is your V1 and V2? So, indicating this one, so manipulation of your equation, we have V1 over 2 minus your V2 over 2 plus your V2 over 4 is equal to 6 plus 3 is positive 9, which is equal to negative 9. Tama? So, we have our V1, which is equal to, ano yung V1 natin? It is equal to 0.5 V1. Right? 0.5 V1. Well, okay, 0.5 V1 minus your V2, 1/2 plus 1/4. It is equal to 3/4, tama? 1/2 plus 1/4. So, another tip na pag kahit sure na kayo at may calculator naman kayo, okay, mag-calculator kayo, guys. Okay? Kasi sayang din yung 1 point. 0.75 V2 equals negative 9. Okay. So, therefore, we have already 2 equations. Which is, this will be your equation 2. Okay. So, paano natin isosolve yan, sir? May dalawa tayong, marami tayong method sa pag-solve ng 2 equations to unknown. Di ba? May substitution, may cancellation, meron tayong Cramer's rule, meron tayong calculator. Okay? Ano mas sure? Calculator, di ba? So, therefore, solving for your V1, so, shift mode. Okay, nakalimutan ko na rin, no? Mode. Okay, mode. Mode. Tapos, hanapin nyo yung AX plus BY equals CN sa calculator nyo. Okay? And then, we will input the values. So, the values are 0.8 equals negative 0.5 equals negative 6. Yan. And then, we have 0.5, negative 0.5, 0.75, 0.75 equals, and then, your negative 9. What is your V1 and V2? So, solving for your V1 is equal to 0, And your V2 is equal to 12 volts. Okay? You may also try your Kramer's rule, which I have shown into your modules. So, pag may mga queries kayo sa solution natin, pwede lang kayo mag-chat sa akin. Okay? Or sa GC na lang para makita ng karamihan. Okay guys? So, take note of the example. Okay? Let's solve for your second example. Yan. So, we have our second example. Yan. So, take note find the voltage VO. And this time, your VO is not equal to ground. Okay? So, it was indicated in the problem that your VO is equal to this one. Okay? Let's have our first step by choosing our ground. So, naka-indicate na dati sa problem yung ground natin. This is our VG, which is equal to 0 volts. Okay? 0 volts. So, anong next na gagawin natin? Sir, ang daming node yan. Meron tayong 1, 2, 3, 4 nodes. Hey guys, bakit 4 nodes yan? Di ba? So, paano natin nasasolve yan, guys? Go back to the principle of your parallel resistance, wherein each terminals are connected only in one node. Tama? So, therefore, pwede ko itong isulat na ganito. I have, yan, may 10 ohm. 10 ohm, yan. May 20 ohm. 20 ohm. May 30 ohms. 30 ohm. And then, may 2 amperes. And then, yung 60 ohms natin. 60 ohms. And then, your 10 ampere. Yan. So, let's say this will be your node VO. Tama ba? So, therefore, anong makukuha natin? Equation. So, pwede natin ganun, isulat ito ng ganito, di ba? Based on our previous discussion. Okay? So, it is just all about your imagination. Correct imagination. Okay? Correct imagination. Kasi may mga nag-imagine sa inyo na mali, di ba? It's about correct imagination of the circuit. Okay? So, how will you get that correct imagination of the circuit? By solving every day. Yan. Yun lang yun, di ba? So, what are the currents entering to your 10 ohms? So, it was indicated that it is equal to your I1. And then, the current entering to your 10 ohms was indicated as your I2. And then, yung I3. And then, your I4. Yeah. Okay? These were correctly indicated. These were the assumptions of your current. Okay? So, how will we solve this one? By KCL. KCL at node VO. KCL at node VO, we have currents entering to the node, we have 10 amperes. Current going out to the node, we have 1, 2, 3, 4. Negative. Negative I1, negative I2, negative I3, and negative I4, and your negative, wala. Negative I4. Hanggang negative I4 lang tayo. Minus 2 ampere. Equals 0 because the summation of IN must be equal to 0 based on the principle of conservation of charges. Okay? So, may 10 ampere ka at may 2 ampere, negative 2 ampere ka. Therefore, I may say that my I1 plus I2 plus I3 plus I4 is equal to 8 amperes. Okay? Or 8. Simply 8 para hindi na lang kayo malito. But what is my I1, my I2, and my I3 and I4. So take note, based on the principle of your voltage analysis, nodal analysis, we have VO minus VG divided by our R. It is equal to IN, wherein IN is any current present in the node, right? So your IN, so let's say I1 is equal to VO minus VG all over my R1. So i-indicate ko na lang din na RN to, wherein the current in your resistor N. Okay? So we have I1 equals VO minus VG all over R1. But what is my R1? My R1 is equal to 10 ohms. Therefore, my I1 is equal to VO. But what is your VG? Your VG is 0 all over your R1, which is equal to 10 ohms. So therefore, your I1 is equal to VO divided by 10. Right? And then, it follows naman. Yung I2 mo is equal to VO minus 0 divided by 20. Therefore, your I2 is equal to VO over 20. And then, next is my I3, which is equal to VO all over 30, di ba? VO minus 0 divided by 30, tama? So, we have VO over 30, and your I4 is equal to VO over 60, right? Or, okay, VO minus VG or VO minus 0 all over 60, okay? So, these are our currents. So, we have I1 plus I2 plus I3 plus I4, napakadali, di ba? We have VO over 10 plus VO over 20 plus VO all over 30 plus VO over 60, which is equal to 8 ampere. Okay? So, solving for our VO, we have an equation equal to VO multiplied by 1 over 10 plus 1 over 20 plus 1 over 30 plus 1 over 60 is equal to 8. Right? Solving for VO, therefore I may say that my VO is equal to 8 divided by 1 over 10 plus 1 over 20 plus 1 over 30 plus 1 over 60. So guys, pag pinansin nyo na mabuti, ito is the total ng parallel resistance nyo, tama? Pag nakarelate pa kayo dyan sa first lesson natin. Okay? So, calculate the VO using your calculator. So, pag may calculator kayo dyan, pakilabas yung calculator nyo, then, mag-solve kayo. So, we have 1 over 10. So, 1 over 10 plus 1 over 20 plus 1 over 30 plus 1 over 60 is equal to VO equals 8 divided by your 0.2, which is equal to 8 divided by 0.2 is equal to 40 volts. That is your VO. Okay. So, solving for our I1, I2, and I3, and I4, therefore I may say that my I1 is equal to 40 divided by 10 is equal to 4 amperes. VO is equal to 40 divided by 20 is equal to 2 amperes. And then, our VO is equal to 40 divided by 30, which is equal to 0.75. 40 divided by 30 is equal to 1.33 amperes. And then your VO over 60 is equal to 40 divided by 60. It is equal to 40 divided by 60 is equal to 0.667. Okay. So these are our currents. At I4, we have 0.667. At I3, we have 1.33. At I2, we have 2 amperes. And at I1, we have 4 amperes. So, based on the law of your charges, therefore, if you sum up the total of this I1, I2, and I3, and I4 must be equal to the I source. When in our I source is equal to 10 minus 2 is equal to 8 ampere. So, pag kinuha natin yan, it is equal to 8 ampere. And the summation of I n is equal to 8 ampere minus 8 ampere is equal to 0. Bakit naging minus 8 ampere, sir? Kasi transpose ito, di ba? I1, ito. Negative I1 minus I2 minus I3 minus I4. Tama? It must be equal to 0. Okay? So, these are our currents. So, remember the steps. Pag walang binigay na ground, okay, create a ground before solving. The ground will be your datum, which is equal to 0 volts, and then indicate the necessary voltage at the nodes. And then, select or assume the direction of your current. And then, if you already assume the direction of your current, huwag niyong babaliktarin habang nagsusolve na kayo sa kalagitnaan ng equations. So, kasi, bakit sir? So, take that, pag binaliktad mo yung assumption mo at the middle of your calculation, the probability is that your current na masosolve mo will not be equal to, the summation of current that you would solve will not be equal to 0. That's why it will violate the rule of our conservation of charges. Okay? Kasi pag binaliktad mo yan, ibig sabihin, pag binaliktad mo yung direction ng current mo, ibig sabihin, pinabalik mo siya. Okay? Ibig sabihin, madodoble siya. Right? So therefore, yung polarity nun, mag-iiba. At pag nag-iba yung polarity ng kahit isa dito sa negative na to, di ba? Magiging positive yung isa dyan. So therefore, your current in is not, will not be equal to your current out, wherein current in plus current out must be equal to 0. Hindi naman nangyayari yan. Therefore, di ba? Therefore, it will violate the rule. Okay? Yan. So, this will be our second example for your first case. The next remaining cases, remaining example will be for the remaining cases. Okay?